All right, let's talk about the very backbone of the modern data center, server management. For way too long, this has been a really complicated, messy business. But, a standardized modern API is changing everything. That standard is called Redfish. And today, we're going to break down exactly what it is and why it's such a big deal. Oh man, if you've ever managed servers, you know this feeling deep in your bones, right? You've got one tool for your Dell boxes, a totally different one for HP, another for Supermicro, and each one has its own clunky, weird interface and proprietary commands. It's just a complete nightmare for automation and a massive headache for anyone trying to get work done. So yeah, let's just frame this problem a little more. Historically, managing the actual physical hardware in a data center has been, well, chaotic. It was just incredibly fragmented. And this wasn't just inefficient, it was a huge roadblock to building the kind of automated, scalable infrastructure we all want. And this really lays out the whole story. On the one hand, you have the old way, all about vendor lock-in, proprietary protocols, and just complexity for complexity's sake. But what the industry actually needed, for modern DevOps and infrastructure as code, is everything on the right. A single, open, secure API that was built for automation from day one. And that brings us to the solution, Redfish. It was developed by the DMTF, that's the Distributed Management Task Force, and it is the industry standard answer to that modern need. It's designed to be the universal language for all your data center hardware, and I mean all of it, not just servers. So what is Redfish exactly? Well, at its core, it's a RESTful API. It uses standard web technologies that you already know, like JSON and HTTPS. And honestly, that's the most crucial thing to get here. If you understand how web APIs work, you are already halfway to understanding Redfish. It's not some crazy new thing to learn from scratch. This is the perfect analogy. I love this. Instead of juggling a remote for your TV and another for your soundbar and the third for your gaming console, you have just one remote that controls everything. That's Redfish. It's that universal remote for your entire data center. And these are the principles that make it so powerful. It's built on REST, it uses JSON that you can actually read, and it leverages web standards like HTTP and OData. But that last point, that one is really clever. By separating the protocol from the data model, it means the what, the data about the servers, can evolve and get richer over time without ever breaking the how, the way you talk to the API. It's future-proof by design. So how does this actually work in practice? Let's demystify it, because honestly, when you peel back the layers, Redfish is just a web API. You can interact with it using the same tools you use for any other web service. Just look at this. The whole thing is so elegant. The API is structured like a website with a logical, predictable path. This simple URI, for instance, that's the end point to get all the information about the first computer system in the rack. It's completely discoverable. You can just browse through it. And since it's a RESTful API, Redfish uses the standard HTTP verbs that we all know and love. You use a GET request to read data, like, say, checking the power status. You use patch to update a setting. Post creates something new, and delete, well, it deletes it. It's simple, it's standard, and it's incredibly powerful. Now, this distinction is really important to get. A static interaction is basically read-only. You're just observing the system's state with GET requests. But a dynamic interaction is read-write. You're actively managing the system with patch, post, or delete. And understanding this difference is the key to figuring out how we can test our automation scripts. Okay, so all of this is great if you've got a whole rack of brand new servers to play with. But what if you're a developer? What if you need to write and test automation scripts without having any physical hardware at all? Well, that's where emulation comes in. I mean, this is the million-dollar question for every DevOps engineer out there, right? You can't just go and ask your boss for a multi-$1,000 server every single time you need to test a simple script that reboots a machine or updates firmware. There has to be a better way. And here is that better way. The very same organization that manages the Redfish standard also provides a brilliant open source emulator. It's this lightweight program that you can run right on your laptop, and it perfectly mimics a real Redfish service. This lets you develop and test all your code against a fully featured, totally realistic API endpoint. And the flexibility here is just fantastic. You can run it locally with Python if you want. You could push it to a cloud platform for your whole team to share. Or, and this is my personal favorite, you can just pull the Docker container. for a completely portable, isolated, and repeatable setup every single time. And look how easy it is to configure. It's just a simple little JSON file. Hey, remember that static versus dynamic mode we talked about a minute ago? You control that right here. You can set static to enable and run the emulator in a read-only mode with mock data, perfect for testing your monitoring scripts. Then, when you want to test actions that actually change things, you just flip it over to a dynamic mode. It's that simple. Okay, let's bring this all together. So, a standard API for hardware, that's great. An emulator to develop against it? Even better. But what does this actually unlock for you? Why does any of this really matter? This right here, this is the payoff. These are your new automation superpowers. You can write one script to update firmware and have it run against any server from any vendor that speaks Redfish. You can perfect your monitoring and provisioning scripts on a plane from your laptop with zero hardware. You can start treating physical bare metal servers just like their cloud instances in your CI/CD pipelines. This is an absolute game changer. So I'll just leave you with this question. Forget all the limitations of proprietary tools and vendor lock-in for a second. Just imagine a world where every single piece of hardware in your data center, servers, storage, networking, the whole shebang, speaks the same modern automatable API. What could you build then?